Imagine you are floating at the edge of the Milky Way, 90,000 light-years from home, and your instruments just picked up something impossible. Your ship isn't moving toward anything. There's no star pulling you. No planet. Nothing you can see. And yet you're accelerating. Something massive is out there. Something with more gravity than every star in the galaxy combined. You can't see it. You can't touch it. You can't even prove it's really there. But it is holding an entire galaxy in its grip, and it has been surrounding you the whole time. Here's the part that should terrify you. This isn't science fiction. This thing is real. It's here right now, wrapped around our solar system like an invisible hand around a throat. Scientists gave it a name almost a century ago, and they still don't know what it is. They call it dark matter. From a distance, the Milky Way looks peaceful. A slow, glittering spiral of hundreds of billions of stars, turning gently through the black, patient and eternal. Photographers call it beautiful. Poets call it home. On a clear night, you can step outside, look up, and feel like you're staring at something serene. A cosmic painting, frozen in time. But something is wrong with that picture. In the 1970s, astronomer Vera Rubin pointed her telescope at spinning galaxies and discovered something that should not have been possible. The outer stars, the ones farthest from the galactic center, were moving far too fast. By the laws of physics we understood, galaxies spinning that quickly should have torn themselves apart. Their stars should have been flung into the void, like water flying from a spinning wheel. They should not have existed. And yet they were there. Calm. Intact. Spinning at impossible speeds. Something invisible was holding them together. Something with mass. Something with gravity. Something we could not see, photograph, or touch. But we could see its shadow. And that shadow was enormous. The beautiful spiral in the sky wasn't just stars anymore. It was a shell. And underneath that shell was something far more disturbing. An invisible structure with roughly 5 times more mass than all the ordinary matter we can see. Now imagine the Milky Way as a city. Every star, every planet, every nebula you've ever heard of, all of it fits inside the buildings. Dark matter is the entire empty space around the city. Except it isn't empty. It's the ground the city is built on. It's the invisible structure holding everything together. And it is pressing in from every direction at once. This invisible ocean is so massive and so vast that our entire visible galaxy sits near its center like a single grain of sand inside a mountain. And you have never been outside it. You are inside it right now. As you sit there, reading this sentence, dark matter is passing through your body. Through your skin. Through your bones. Through your blood. Every second of every day. But here's the problem. We don't just not know what it's made of. We don't know whether it can hurt us. And that uncertainty may be worse than any answer could ever be. Gravity is supposed to make sense. You drop something, and it falls. A planet orbits a star because the star's mass pulls it into a predictable curve. Simple. Elegant. Understandable. But dark matter doesn't fit neatly into that picture. It doesn't form stars or planets. It doesn't create ordinary surfaces. Instead, it appears to exist as a vast invisible distribution of mass, exerting gravity across enormous distances. Every 225 million years, our entire solar system completes one orbit around the center of the Milky Way. And dark matter is part of the invisible gravitational structure guiding that motion. Without that hidden mass, the galaxy would behave very differently. And then the story becomes even stranger. Our solar system may not simply sit inside this invisible ocean. Now picture this. Somewhere beyond the edge of our solar system, a region of something invisible moves toward us. No light. No heat. No sound. Nothing your eyes could ever detect. And yet, if dark matter interacts with normal matter even slightly, Every moment of every day could involve particles passing through you without leaving an obvious trace. You wouldn't feel them. You wouldn't hear them. You wouldn't even know they were there. But that's not even the worst part. We don't actually know how dark matter behaves. We don't know whether every region of it is equally harmless. We don't know whether there are denser clumps, invisible knots scattered throughout the galaxy, capable of effects we haven't detected yet. Humanity has spent decades trying to find out. Scientists built enormous detectors deep underground, sometimes beneath miles of rock, shielding them from cosmic rays and other interference. The goal was simple. Catch a single dark matter particle interacting with normal matter. Just one. After decades of searching, the evidence remains frustratingly elusive. Not necessarily because the substance isn't there, but because it is incredibly difficult to detect. Think about what that means. Humanity has created machines sensitive enough to search for incredibly rare subatomic interactions. We have placed detectors deep beneath mountains. We have isolated experiments from enormous amounts of background noise. We have watched the universe with some of the most advanced instruments ever constructed. And whatever dark matter is, it continues to hide. It appears to have more mass than all the visible matter around us combined, yet it refuses to reveal its true nature. Then came one of the most important pieces of evidence. In 2006, astronomers studied something called the bullet cluster. It wasn't a normal collision. Two enormous galaxy clusters had slammed into each other at tremendous speeds, creating one of the most violent events. And this is where the story becomes truly terrifying. Dark matter isn't just shaping the history of our galaxy. It may be helping determine its future. Dark matter acts like a hidden gravitational framework beneath the visible universe. Without it, galaxies would form differently. Cosmic structures would look different. The universe we know might never have existed in anything like its current form. And eventually, that invisible structure may help determine what happens to everything. The universe is expanding. Galaxies are moving farther apart. Over unimaginably long periods of time, stars will exhaust their fuel. New stars will become increasingly rare. The universe will grow colder, darker, and emptier. Trillions of years from now, the brilliant night sky we know today could become almost completely dark. The stars we see above us now may eventually become isolated islands of light in an enormous, freezing universe. And we cannot control that ending. We can't even see all the forces involved. Astronomers estimate that everything we have ever observed directly, every star, every planet, every galaxy, every nebula, and every object captured by human telescopes, represents only a small fraction of everything that exists. The rest is hidden. Dark matter. Dark energy. Two enormous pieces of the cosmic puzzle that we still don't fully understand. We gave them names because humans need names for things we cannot explain. But naming something is not the same as understanding it. We measured its gravitational influence. We watched galaxies respond to it. We mapped its invisible fingerprints. We built detectors beneath mountains to catch it. We studied galaxy clusters smashing into each other. And still, the substance itself remains almost completely invisible. Almost a century after the first clues appeared, we still don't know what dark matter actually is. We don't know whether it is made of particles we've never discovered. The Milky Way above you looks complete. The stars seem to tell the whole story. But they don't. Behind every point of light is an invisible gravitational structure stretching far beyond anything your eyes can see. You are standing on a tiny planet, orbiting an ordinary star, inside a galaxy that is itself moving through an enormous invisible ocean. And you have never been outside it. You cannot step away from dark matter. You cannot shield yourself from it. You cannot turn it off. If it exists the way our best models suggest, it has been surrounding Earth for billions of years. It was here before humanity. Before civilization. Before the first animals walked on land. Before Earth had oceans. And it will probably still be here long after we are gone. That is what makes the mystery so unsettling. Dark matter isn't some distant object at the edge of the universe. It isn't hiding millions of light years away. It is here. Around you. Through you. Inside the same galaxy you call home. And somehow, despite being surrounded by it every moment of your life, you have never directly seen it. We've spent generations trying to understand what is holding the universe together. We have watched galaxies rotate. We have measured gravitational lensing. We have observed enormous cosmic collisions. We have built detectors in the deepest places on Earth. And after all of that, we still have more questions than answers. Maybe one day, we will finally discover what dark matter is. Maybe we will find the particle. Maybe we will uncover an entirely new layer of physics. Or maybe the universe will continue refusing to give us the answer. Because perhaps the deepest lesson isn't about dark matter at all. It's about how little of reality we actually experience. The universe was never designed around human senses. Our eyes detect only a tiny range of electromagnetic radiation. Our instruments extend that range. Our equations reveal things our senses cannot.